A blessed day everyone. In this video, we will be presenting to you the documentation of our experiment.
Now I'm gonna be showing you the materials needed for this experiment. 10 jars, 1 to 2 cup size, about 250 to 500 ml of fresh water. Salt water, adding the salt to fresh water about 0.5 grams per cup of water. 2 to 3 inches long of the following nails. 2 standard bright nails. 2 standard bright nails bent to a 90-degree angle. 2 galvanized nails. 2 galvanized nails with galvanizing removed in one area. 2 copper pennies or copper foil and aluminum foil.
For the procedure, first, fill 5 jars partways with fresh water, labeled as fresh water. Next, fill 5 jars partways with salt water, label it as salt water. Introduce one set of each type of nails into 4 fresh water jars. Introduce the second set of each type of nails into 4 salt water jars. In the 5th fresh water jar, introduce a piece of aluminum foil, then place a penny on top of the aluminum foil. As well as for the 5th salt water jar, introduce a piece of aluminum foil, then place a penny on top of the aluminum foil. On the standard bright nails, for the fresh water, only the 2 tip of the standard bright nail got rusted, while in the salt water, the whole standard bright nail got rusted. Now on the standard bright nails bent in 90-degree angle, in fresh water, the whole standard bright nails that bent to a 90-degree angle got rusted, and in salt water, the whole standard bright nails that bent to a 90-degree angle got rusted, but as we can see, the nail in salt water is much more severe in rusting than in fresh water because the corrosion in salt water is faster than the fresh water.
In fresh water, a little portion of the galvanized nail deteriorates or turned into color black since it has a galvanized coating that prevents it from rusting and corrosion. In salt water, the galvanized nail deteriorates quickly. As we can see, the black part in the tip and some parts of the galvanized nail were caused by the salt water. In fresh water, the galvanized nail with galvanizing removed in one area quickly deteriorates since the galvanization that protects it from rusting and corrosion was removed. And in salt water, galvanized nail with galvanizing removed in one area also deteriorates, but it is much more severe than in fresh water. Its tip and most of the nail also turns into black, which is a result of rusting and corrosion. In fresh water, rather than rusting, the foil deteriorates and the copper penny fades and doesn't shine anymore because it has been covered by a layer of green caused by corrosion. In salt water, there is essentially no rust on aluminum foil and copper penny, just like in fresh water. The copper penny also lost its shine just like the one in fresh water. Both aluminum and copper penny did not rust, but a layer of green again appeared on the edge of the penny.
After all the observation and information we have successfully gathered, we concluded that oxygen, hydrogen, electrical current, dirt, and specifically even germs can make metal corrode when it reacts with metals. Metals like steel under excessive stress as well make corrosion. Salt water is more corrosive than fresh water because of the higher conductivity. Chloride in salt water can destroy the oxide film on the surface of metal and form a complex with the metal ions, producing hydrogen ions during hydrolysis.